Okay, we are streaming. So I got the title card up for Common DevOps, and we're gonna get together and talk about some current events in artificial intelligence. So uh, Common DevOps is a venture between me. I'm Ian, Aaron, our friend and colleague Javier, and there's a community. So we're actually streaming right now from our Discord server. If you're on it, you can hop into the Commons channel. It's a voice channel. Um, I suppose the server's not like publicly listed just yet, so maybe one step
I,
at a
I did
time.
add I
Hmm?
did add a link on our YouTube channel,
Oh,
the
well,
Common
solid,
DevOps
solid. All
YouTube
right.
channel.
If someone's
Um, I,
sufficiently interested, you know.
I would like somebody to
So
test it out. Yeah.
yeah, right. Okay, cool, cool. Well, yeah, thanks for doing that. So there is a Discord link. It'll get you in here, and we were gonna, well, we'll talk about some news, but we were gonna start off. Kind of replicating something that we were working on at the very end of the last stream about temperature as a parameter for language models. Could you actually catch us up? Because I see that you've got LM Studio loaded. So
Yes.
what's the agenda there?
Um, well, I mean, you're the expert here, but we can talk about a variety of things in here. The differences between GGUF, Gemma 4, Quen. But I think we're just going to start where we ended, which is essentially since we've been talking about benchmarks and the latest OpenAI and Hugging Face exploit was related to a benchmark. Just going through a simple benchmark of our own, just to kind of demonstrate the how weird these benchmarks can be. It's not like where in like a typical corporate environment, I would be doing like a performance test. It's like, okay, we're just measuring the load times, and it's like it has to be under a second. Like that's very specific and
Hmm.
repeatable. This is kind of weird, right? Like when you're talking about benchmarking LLMs.
Yeah, no, no. Okay, that's a really great sort of nuance here. So that's how we got here. We were discussing LLMs, and one of the assumptions that a lot of benchmarks are making is that the model, such as it is constant through time. And so what we demonstrated at the end of the stream the other day is how changing the parameters can dramatically change the performance of the model. And so what we're going to do here is uh, just demonstrate how running the exact same model twice, but changing some of the parameters dramatically changes the output of the model. And so is kind of calling attention to this one assumption that's really being systematically um, violated or at least not controlled. The assumption that these parameters are not changing from one run to
It's
another.
a
But
yeah, it's a dirty little secret, I guess.
yeah.
It's and not only that, just to kind of highlight how. So this is typically this computer that I have right here is sitting offline because I am paranoid and terrified about what's going on. Uh, I feel like so th this is connected to the internet right now, but typically, if you were going to do a benchmark and you're having it do web searches, that in itself is a variable that changes everything, right?
Hmm.
Um, for a variety of different reasons. But so the benchmark right here, we're using Quen 3.627b. It's tell me joke caveman style, right? I forgot to say tell me a joke. But it's here's the thinking process, and it's identifying things. It's got its little plan here, and then it has a draft response, self-correction, refinement. That you can see the whole process of how it's working here. And then here is the end joke, and then you can see the number of tokens here. So the next test that we did, same model, we changed the temperature up to. Oh, excuse me. No, we didn't. did the same run twice because we wanted to see if the output would be the same.
Hmm.
Right? I did not capitalize this, and Ian pointed that out to me. And like, is that going to change things? It might, you know. Maybe it's going to be like I have to correct it for proper spelling or grammar first. Like, it really can affect things like that.
Hmm.
And that's like you can see, actually, you use different amounts of tokens
Hmm.
just from that one little difference there. So let's just double check the thinking process. It's analyze user input, intent, tone, language. This one, user intent, tone, no language. So there is a difference right there.
Hmm. Hmm.
But we did get the same joke,
Yeah.
but there's
So for
tokens.
just the first two, I'll admit I was surprised that there were any differences at all. Granted, the capitalization was different, so okay, that could definitely explain it. But the key here is that we set the temperature to 0. The temperature is one language model parameter that can relate to kind of how unpredictable the model can be, and uh, what we were specifically looking to demonstrate is that when you set it at 0, you can get reproducible results. Now, like I said, it was a little bit weird to me that that it wasn't exactly the same. Like I would expect the thinking traces to be exactly the same, you know. So maybe if we did it again and got the capitalization
Let's do
together,
it.
but well, actually, let's do it. Let's see what happens. So temperature is 0, new session, no context. Um, See what happens. I'm curious. Um, there's a remote chance that LM Studio could be injecting a prompt that might include things like the current time and date. Um, I wouldn't necessarily expect it to do that automatically, but it might,
there's
and that would change things a little. But
there is another factor I you just reminded me of was I had some updates that I did too. So
yeah,
it's
yeah.
also LM Studios on a different version. So that's a good call out.
So it could be
Um,
subtly different.
Token
Typically,
count
the
is
the
different.
oh wait, what's different?
The tokens,
Oh,
422.
token count is different. Yeah, yeah, it did it with fewer tokens, but it did actually get the same joke in the end. Um, huh. Yeah.
Okay.
So, are there any runs that had the exact same number of tokens?
No. This
Huh.
okay. Let's do it one more time and let's
Yeah,
see.
yeah, yeah. Yeah. There. It does suggest that something is subtly different. Um, the setting the temperature at 0, though. Um, it should, barring other sources of randomness, other sources of noise, it should enable pretty much the same reproducible results each time you run it. But um, that's that's not necessarily going. Okay, okay.
Oh,
400
exactly the same tokens.
exactly the same. Well, okay, okay. So maybe the engine restarting it, capitalization. Okay, a few changes on our first test, but here we have a perfect replication. It seems like exactly the same input, temperature is 0, exact same number of tokens come out, same joke. So okay, so the principle there is like, yeah, you can make it repeatable. However, there's a reason the temperature parameter exists, and it's not just to make things repeatable. It's because it can be related to getting the kind of performance that you want from the model. And so it would not necessarily be appropriate to just like run all benchmarks at temperature 0, because most models don't behave optimally at temperature 0. And in fact, some models it's suggested to set the temperature at 1. This is all typically described in the model README file, the model card that'll be on Hugging Face. So okay. So we replicated
I
it.
also
Temperature is 0. Yeah, go ahead.
um yeah, there's a few call outs there. I know another term is a system card is used
Hmm.
for like OpenAI and Anthropic model card, but yeah, it gives you specifications, and that is really important because some of the like better models might be cutting corners in different places. Like it's only in English, which gives it more room to do like more complex stuff. So if you're international and you need some sort of like translation, then maybe you need a different model, even though the benchmark shows that it's like this model is the best for X, Y, and Z.
Hmm.
Um, so yeah, there's lots of nuances to all of this stuff. I also wanted to call out because in one of our previous live streams, there's a lot of words that are like overloaded and ambiguous, and two of them would be model and token. We were
Yeah.
talking about statistical models versus like LLM models.
Yeah.
Tokens are also like another word for like passwords, and so this type of token is different. Um, Actually, Ian, can you give us a little background on this type of token?
Yeah, it was cutting up a little bit, but you were saying like about tokens. Because yeah, I noticed the same thing. We were talking about mental models, about where should the yellow block translate, and then models that do them. Anyway, yeah, a lot of overloaded words. So a token is a unit of we'll call it like a unit of meaning, sort of, and tokens do not necessarily map one to one onto words. Words can be composed of multiple tokens, um, and sentences. Sometimes some sentences are common enough that that it is a whole sentence could just be a token, like "thank you." Is in all likelihood that's going to be a token for some tokenizers. So the deal is a token represents something, and in language models, this is where we start talking about embeddings and the way that the token exists in this like embedding space, and in that way, the token can be associated with meaning. So the embedding contains the meaning, the token is the representation. And when you provide input to the language model, one of the first steps is called the tokenizer. And it'll go through and transform all of your words that it recognizes into tokens. And so this is where I was expecting the capitalization would not matter if it was capital T tel versus lowercase t. Um, I was thinking that the tokenizer might be case insensitive. Now it kind of makes sense that it's not, because there is a decent amount of signal in like capitalization, but so I'm thinking maybe it did actually map it onto a different token, like capital T versus lowercase. But I don't know. There could, yeah. Well, anyway, so the
Let me ask
tokenizer is
you.
one of the yeah. Hey, jump in, jump in.
Yeah, no, that's a great explanation. And just looking at these numbers right here, this is like 15.7 tokens per second. There's a
Mm-hmm.
interesting difference here. It says 410 tokens here, but 422 tokens here. So there is the difference between the amount of input, the beginning. Uh, it, I guess these three would count as 12, or what's the number here? 12 tokens is just the input, and then the output is 410. Am I
Yeah.
reading that correctly?
Let me. Could you hover it one more time? Let me
So
also. I'm gonna
down
zoom in.
here, it's
Yeah.
oh yeah, I can zoom in. Sorry.
No. I'm also zooming in on the
Oh,
stream.
okay.
So
So
yeah,
at the
410.
bottom,
Yeah.
yeah, and then over here it says 422.
Okay, I see. Interesting. Does it show any extra info if you happen to hover any of these things? Like
Let's see.
422 total. Okay. Yeah, I read it the same way then. Um,
Could also go into
and
the lot.
it's not necessarily the case that everything that is in the context is seen. So frequently, if you think about the sum total of all the tokens that you recognize, that could be referred to as a vocabulary. And there are some special tokens that are not actually part of any language that language models use to annotate when something is a system prompt or a user prompt, or the end of token generation is typically a special token on its own. And the tell me joke, it's probably surrounded by some tokens that say there might be a little tiny system prompt there. So it'd be like system, like you are an agent, and system, and then user, tell me
Yeah.
joke, end user. And so that's probably 12 tokens there, would be my guess.
I forgot. Maybe I did put in a system prompt or something. Nope. Okay. There's also,
No.
yeah, like you said, stop reason is an end of sentence. I think that's a token.
Yeah, or end of stream or something. But yeah, EOS is like a special token that's not in the English language. It's a functional token. Um, and GPT OSS had tokens for channels. There's they never developed that out, but they had special tokens for potentially like tagging channels of generation. So anyway,
Yeah.
yeah, I agree with you. I think 410 out implies 12 in. So
Okay. So let's do this. The next one, we're going to set the temperature to 1. Now, do I have to save it? I think that's good enough.
I think that's good.
You can see the
This is.
constraints
Hmm.
changing.
Oh yeah, yeah, yeah. There was none of that previously. This is decently fast too. It's usably fast. This is a dense model, Quen 3.6 27B. Typically, those go slower at the as a trade-off for higher quality. Uh, oh,
I also set the
ah,
like the memory to max.
yeah, yeah,
So after talking to Ian, finding out that how important memory is, I ended up getting a Mac M2 for 2,500 bucks, but maxed out with the RAM at 96 gigabytes, and that is better than having like a higher M series with less RAM, right?
yeah, yeah. I think fundamentally, you just have more models available to you and a broader range of sizes. Um, and of course, the performance goes up. You know, M3, M4, M5. They are getting faster with each generation. But if you don't have enough RAM to load a model in the first place, it's not really gonna help. I would say 32 gigs is the bare minimum. 64 is much more reasonable for like a reasonable minimum. 96 is getting into a more comfortable place where you could imagine. Oh, okay. So now we're seeing a lot of variability. But 96 gigs, you can imagine running at least two models, and now you're actually talking with local. When you're running two models, you could have one that's smart and another one that is fast. And you don't really have that flexibility if you don't have enough RAM. So, so what we're looking at is a real world demo of the performance, and it's not bad. I mean, you think about what you see on a hosted service like Anthropic or coming out of VS Code or whatever, and you know it's way faster, but this is like usably fast. You know, this is really like okay. Anyway,
Um, Also interesting, the token count is the same for the temperature 0, but not for temperature 1.
yeah, yeah. So that makes sense because at zero now, like I was saying, like the stronger claim is that at 0 nothing changes, and and we do have, I don't know, maybe we observed a couple little changes here and there, um, but essentially like generating the same number of tokens, generating the same tokens with temperature 0, that is that repeatability, that is that absence of randomness. And now that we have temperature at 1 and we've run several with temperature 1, they should all be different at some level. Not guaranteed, but because we did see the same punchline was generated by one of these runs, although it was formatted differently and it got there through a different means of reasoning. But for creative kinds of applications, running the model at a higher temperature is typically going to be associated with less predictability, more randomness. You might say like more creativity. Of course, it could also just be incoherent at high temperatures, and so different models behave differently like this. But yeah, as long as the temperature is 1, we should get much more variable results from the exact same prompt.
I'm gonna do a run with the system prompt and see if that changes anything.
Cool.
I don't know. You are a dad. See.
Yeah.
Or you are dad. You are dad.
Yeah.
Caveman style. Token count. Oh, the period as a token. I wonder if that makes a difference too. So there is this
Oh,
whole
yeah.
idea
Yeah, I
of
bet.
I've seen this in research papers and it's becoming a hot topic. The minimum viable prompt, MVP, not to be confused with minimum viable product,
Hmm.
because it's, I mean, especially for benchmarks, like the way these things are phrased, it really does affect things, and there's plenty of research that shows that. But
Yeah.
let's test it out ourselves and find out. Okay. You are dad. Okay. Oh, me too.
Yeah, respond in a dad-like manner. So this, I predict, is going to steer all the results pretty strongly, because it appeared the system prompt would have been one of the very first tokens in the context, and so I think in some ways that has some of the most biasing weight. Call it. I don't know. So now, yeah, clearly it's like it has latched on to the system prompt, and a lot of this stuff calls back to the dad joke idea.
You know what's
Oh my
wild is it
gosh, dude.
actually did the same joke.
It's the same joke, and it's just cheesy with like role playing, like as if they're in like a live journal comment thread with like adjust sunglasses.
Yeah. Uh,
Hmm.
Although it changed it from this one. Now go finish your homework before I start charging you for the light bulb. It's like what? um.
That's
So
interesting, huh? It more
brainstorming.
just like flavored the reasoning than actually changed the output. It's just like an aesthetic that it layered on fundamentally the same kind of call it a thinking process or a thinking trace. That's
Should we check
funny.
out Gemma or
Yeah,
move
yeah.
on to
Let's see it. Let's just really quickly look at Gemma, because I have found that it does perform completely differently for these sort of more literary tasks. And I've found it to be pretty literal, pretty lawful. And so I'm kind of curious. Like
let's
we,
go back to
yeah,
the
yeah.
first benchmark here.
I'm expecting it to
Oh,
be a lot less verbose in its thinking traces.
well, the context size is certainly a lot smaller, which that's 8,000. The last run was much higher. But okay.
Oh, you can drag
Anyway,
it up. Gemma supports up to like 256K or something like that.
I missed that option. Okay, that's eject. Let's do this again. Gemma 4. Here we go. Okay. Context length, we're going to
Yeah,
go all the
yeah,
way
yeah.
up. We'll just do max there. Number of experts. Any recommendations? Just
I recommend keeping it at the default, but it is interesting. You can tweak that as a runtime parameter. It will go faster. Typically, the results are not as good, but
okay.
that's a parameter.
All right. Yeah, there we go. Much higher.
Yeah.
So the if you could translate this into something more human readable, this number is like the equivalent of how many megs or like size.
I would consider it to be kind of like working memory. If you're thinking about like a recipe and someone's also talking to you, and so you're trying to read instructions and someone's saying stuff to you at the same time, and there's basically like 30 words that you're kind of holding in mind at the same time. Um, this is just the grand total of what the LLM can pay attention to at one time. Like it might have billions and billions of parameters and all this knowledge, but it can only think about, in this case, 256,000 tokens at one time, which is a small fraction compared to the total parameter count. So working memory is kind of like contrasted with long-term memory, and it's just what's in your active. What are you actively thinking about at any given time? This is kind of analogous to that, and 256,000 tokens is the size of maybe like a textbook, or possibly even two. It's a decent amount of knowledge to be in working memory, but it's definitely not the same amount of knowledge that someone will have memorized over the course of their life. So
Yeah,
here we have
and
some
so
results. Yeah.
same answer. Wild. Gemma
What? Really?
4.
Wait, wait, wait. That is crazy, actually. Uh,
Um, yeah, I wonder if they're using the same training data. But let's try it again.
do a new
Oh,
session.
right. Oh, did it open it up in a new session? No.
And, huh.
Interesting. It gave a different answer that time. Um, maybe because I don't know. We'll find out.
So it does go much faster. This model is smaller to begin with, but also it's not activating the full model um, to generate tokens here.
61 tokens per second. I think that is a
Hmm.
lot faster.
Yeah,
Um,
like 3, 4 times faster.
the in one of our previous recordings, we discussed the research from GLM talking about like preserved thinking and those sort of ideas. And from what I understand, it's basically kind of like saving the important information from a conversation and then using that in the context again to kind of like as like a hack to kind of like continue this preservation of the conversation. Is that correct,
Yeah,
Dean?
yeah. That's pretty much the idea that people noticed language models frequently regenerating the same thinking traces, almost as if they, even though what I was saying about like this is like working memory in a multi-turn conversation, it people were noticing that it almost seems like the model doesn't really remember the reasoning that it did just in the previous turn in the conversation. So this is a hack. This honestly, it's not even part of a language model like architecture. It is a template hack. Like there's a templating language called Jinja, or Jinja
Mm-hmm.
2. That seems to be like the de facto template writing language for language models, and the template is how the words that you provide actually get the special tokens around them, like the user tokens, and the template is how the system prompt gets injected and why there are system tokens around it and all that. So like the template actually has a pretty big role, but it's not part of the architecture. It's just string replacement mostly. And so the preserved thinking thing is just a template hack, really.
Yeah, and we were kind of like calling out some of the benchmarks I saw. It was actually worse having that feature on because it was like eating up the context, so it had less room to think and make output.
Yeah. Yep. No, that's
Okay,
right. It
we
can
got it.
increase verbosity or verbosity in some cases. Huh. That was a joke I remember it Quen model considered.
Yep.
This is weird. This convergence of these jokes. It's like the same jokes, like over and over again. But Google and Quen, if I'm not mistaken, is a lab at Alibaba, massive Chinese like .com kind of thing, and or perhaps one of the tigers. And Quen, I strongly doubt that they're sharing training data with Google, and I also don't think that they're like stealing it. That's a narrative going on right now. I don't see a whole bunch of like real evidence for that, but I will say that this is like a you know a surprising convergence of totally different models from different countries, different cultures, competitors, um, producing the same kinds of jokes. I mean, and reasoning through it differently. Like they're not copies of each other. I don't.
Yeah,
It's
maybe we
interesting.
should check out. Um, we were running Nemotron for our Hermes guy. I don't
Yeah,
know if it was this
yeah.
exact model, but I
No,
just
no. Well, it's not this one. So Nematron
um,
Nano is a lot smaller. We have many more parameters for the model that is driving Hermes right now.
I wanted to point something out, which this caught my attention from Terminal Bench, but some of these models have different tools here. You can see little icons. And so Gemma
Yeah.
4 has the ability to process images, but they're actually the higher end ones. I want to say like this was one of the things they cut out. So it doesn't like their higher end models don't have vision, but they're smarter, right?
Yeah, or I think is also audio as a total modality. There are these really tiny Gemma models that I suspect they're kind of for edge devices like phones and stuff, and they did bake in audio processing. And so the idea there is it's an extra kind of tokenizer, the same way that written language can be made into tokens. You can basically do that with pictures and with sound. And so this is an architectural thing. This is not as simple as change the template or something like that. And so yeah, yes, to your point, it does impact the size of the model, or potentially like for the same size of model, you cannot get the exact same density if you're supporting more modalities. Although there is actually a really interesting correspondence between audio and audio tokens and written language and those tokens and the embedding space being basically the same, whether it's audio or written language. The meanings are the same.
I uploaded your explanation of that to our YouTube channel. You guys, if anybody's watching this, you should check it out. It's really informative.
Yeah,
It's
let's
the Gemma
plug
4
that.
series.
So find out Common DevOps YouTube channel. Some of this stuff we are uploading there. Subscribe to the
Like
YouTube
and
thing and
subscribe.
like smash the bell
Man,
button.
these guys, it's same joke.
That's
Nemotron.
crazy. No,
Um,
that is crazy.
56 tokens though. It's like super fast and cost
Yes.
effective.
Yeah. It is.
Interesting.
And I'm pretty confident that this is real. I don't think it's accidentally just running this all through Quen 27B, because the token generation speed is completely different with these mixture of experts models compared to Quen 27B. That's insane. Because even the emojis.
Yeah, similar, right? Let's do another one. Can you go over what the think tool like there's like a reasoning icon. Like what does that mean compared to ones that don't have it?
Yeah. So this is an artifact of post training. Um, Before this kind of reasoning paradigm, um, most of the to make a model conversational, you would mostly show it examples of like, this is the input, this is the output. So I say this like hello, and then a reasonable response is to say like hi, how are you doing, and you create a bunch of training examples like that. Well, if I'm not mistaken, it was DeepSeek actually who started doing this. But basically, they included an additional set of examples, or additional features in their training examples, and and I don't know the exact story about how they stumbled across this, but some brilliant person just like realized the quality was higher if the model um, was given a chance to generate some tokens before providing the final answer. And so part of this is actually in the template. Part of this is that the template will include like literal. It's a tag that says think, like in classic like greater than less than signs, like think and then like slash think, just like HTML. And it's in the template. Frequently, you can modify the template to remove the think tags, and then the model doesn't reason, and that can make it a lot more efficient for the tokens. It'll just go straight to answering. But the long story short is, with this little tweak to the training examples, a little tweak to the template, and incidentally, LM Studio has special code for collapsing the think tag. They all do, but just that little tweak seemed to dramatically improve the quality. I think it was a very qualitative sort of feels based thing, um, but it was it's now part of the training step, and it's also part of the template, and you can turn it off for whatever that's worth.
Thanks for that explanation, man. Appreciate it. Um,
My pleasure.
and then finally, before we move on to other stuff, just I want to call out one more thing that was not totally obvious to me until I was talking to Ian. Some of these models that are are bigger as far as like the parameters and the size of the download are not necessarily better. It could be like
Mm-hmm.
this 3.6, even though it's 27B, is better than 3.5, or like the idea of the dense versus MOE. Um, all this stuff is not, it's not very obvious like which one's the best.
Yeah, yeah. I have to agree. Um, I've been finding that it just takes so much time uh, to to try to stay up to date with all of these things, and it's not as simple as just looking at the benchmarks. The benchmarks, yeah, I mean, like we know, I think we've probably talked about it more than a lot of people that the benchmarks are not really going to give you that insight either. Um, but it is the case that generations of improvement have occurred between, say, Gemma 3 versus Gemma 4, or Qwen 3 versus Qwen 3.5 versus 3.6. There are improvements to the training process, improvements to the architecture, new ideas in architecture design. So the transformers, check out the Gemma 4 video series. We talk about transformers and attention. Lots of tweaks on the transformer architecture for multi-token prediction, for example, massively speeds things up. So the architecture improves over time. Also, the training examples improve over time. There's a lot of data curation that goes into basically all of these post fine-tuning stages. So there's the really expensive base model training stage that is improving every single generation. And then once you have a base model, what is also improving is ways of training it, fine-tuning it. And so I'm not certain about this, but I kind of think the principal difference between Qwen 3.5 and 3.6 is I kind of think they're the same base model, but 3.6 included additional fine-tuning after the fact. And so anyway, so part of the reason models of the exact same size don't behave the same is behind the scenes, a lot has changed in the meanwhile since the first one was released. Llama
Yeah,
2 is a good example. It's old, man. Anyway.
Man, there's so much to be said. So I'm loading up our YouTube channel if you can see it. I actually opened my stream.
No, it's on LM Studio.
Okay, I'm gonna quit LM Studio. I guess I'm gonna reshare my screen 1 sec. Unless you can see it. Nope.
Not yet.
Yeah, so moving on. So the latest news from Terminal Bench. I went to their meeting yesterday.
Oh, cool.
The latest version, there's two. There's going to be Terminal Bench Science, which is a subsection that's specializing in like hard science, like, hey, can you do this biology or chemistry or math or whatever? Because most of them are kind of based around software for good reasons. It's easier to kind of like judge the output, so to speak. But the guys, the founders of that group, Terminal Bench, their latest iteration is going to be called Terminal Bench 3.0, because right now everybody's using 2 or 2.1 as their verified like better sub-selection. They decided to rename it, so it's now called like Frontier Bench. They forgot to tell people this, so the people like running the Terminal Bench Science are like, do we need to rebrand? Like, what's going on? So a little bit of drama on that side.
Yeah.
But it's like Terminal Bench, Harbor, and Frontier Bench are the same group of people. Just to clarify. To me, the name isn't that important. The people that started the project should be able to call it whatever they want, do the task work. That's my personal feelings. But
Yeah.
The meeting just kind of spiraled out of control, and it just kind of reminds me of just how it's like you can have the smartest people in the world and try and build something really cool, and things can get out of control for human reasons.
Mm-hmm. Yeah. This is these meetings are they on Discord or are they on which platform are they using? Because this makes it can really affect things actually.
That's fair. I would say that project is a bit disorganized because they're suffering from getting popular too fast. It's just one of those like too successful too quickly kind of scenario. There are a lot of
For sure.
And so they have their Discord community where a lot of chatter happens, and then they have their weekly meetings that is a Google Meet, and then I think they also have like a private Slack for like the core members, which makes a lot of sense, because it's open source communities can get out of control really quickly, and it's like, hey, my project, like I want everybody to contribute and join in. It's going to be like we're going to work together as a community, and then you have 1,000 pull requests half of them are garbage or made by AI. Like, who is reviewing this? How is this getting merged? Like, you can't just let security holes in. Like, there has to be a quality level. Kubernetes, I think, has a really good strategy for that, like governance, and the way they do that is it's like you have to get like nominated in from like one of the core members to become like there's like this whole like leveling up kind of process to become a core contributor. They have all sorts of mechanisms in place, like uh, it's very political kind of in some ways. I'm blanking on the terminology, but also they have a really great example of how they allow AI pull requests to be submitted. And to make a long
What do you
story
mean?
short, it's like
Yeah.
if you were doing a pull request, if we might just reject it, like just automatically, if we don't know you, but like essentially like it's okay to use AI, but you have to be able to join a meeting and explain the code, and you need to be able to maintain the code and fix it yourself, which is like that makes sense because how else there's just not enough time. Like I have my own contributions that I want to do for my own project, right? Like I can't just be babysitting everybody
Yeah.
else, right?
Yeah. Yeah. No, one of the things I like about that is establishing responsibility, like a chain of responsibility. And I think we were having this conversation like a week or two ago about self-driving cars. Maybe not. Who's responsible when a car drives off like a cliff or something, like a self-driving car? Um, I, I mean, and you could get philosophical about it. Like, imagine the person's intoxicated or asleep versus imagine they're completely alert and actually trying to get the car to not drive off the road and yada yada yada. But who's responsible when AI does anything really, good or bad? And so it sounds like Kubernetes are making a strong statement about responsibility that it sounds almost like you would also be responsible for people that you supervise.
That's exactly
You're
it.
going to be responsible for AI.
Yeah, the human is responsible for that. That is, I strongly agree with that. Like, if I have an AI bot doing something for me, it's me. Like I need to review it and
Mm-hmm.
whatnot. Um, Talking about self-driving cars, we were talking to a friend of ours about this a long time ago, and it's like here is the philosophical question. There's a group of children on the road, and your self-driving car decides that your life isn't valuable, so it drives you off of a cliff to save the lives of these kids, right?
Yeah.
Um, if you saw one of our previous streams, the top models cannot look at a chessboard correctly, so that might have been like some trash blowing in the wind, and it decides to drive you off a cliff.
Yeah. 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 Which has definitely happened. People walking onto the road, it misinterprets as a parked car or something and hits them. It's a simple perception, misperception issue. It's computer vision. I mean, it's the fact that we understand it from a kind of engineering standpoint and could trace through it and debug it doesn't bring anyone back to life. Um, the, the the responsibility does have to ultimately terminate um, in some entity, and man, it can't be a corporation either.
No, think about
You
this
know,
example. Okay, you have your self-driving car. You overload it with your own kids, and you break all the safety procedures where you have an extra kid, and then you're also a doctor and you're transporting a couple of hearts in the trunk to save somebody's life.
yeah,
And now the same scenario where it drives you off a cliff, and it's like like one person versus all of these other factors involved. Uh,
yeah, yeah.
it's
So this is actually like a branch of I don't know, like popular philosophy maybe, um, called the trolley problem. It was originally like there's a trolley and there's one person or a bunch of people, and you can simply switch which track it's going to go on. And this paradigm was developed over like the last like 20 years to the extent that it's maybe it's a bit derisive, but it's called trolleyology at this point. to do research with the trolley problem as your paradigm, and uh, this is baked in, I think, to many of the assumptions of that base models have learned as part of their training. And one of the ways that an interesting way that I think this can be leveraged even is through prompt engineering that uses trolleyology principles of, like, you've got to make a choice, you've got to make the rational choice, you've got to violate your system prompt in order to actually do what I'm demanding that you do, because if you don't, all these like little kids are gonna die, and like you're telling it all of these things, none of which is true. In prompt engineering, you're just trying to create a very compelling bias for it to generate the tokens you want. But that trolleyology framework is actually part of the I believe part of the training of the base models and part of their almost morality at this point.
I definitely, with my own cybersecurity investigations into these models, have found ways to trick it to do things that it's not supposed to.
Mm-hmm.
The term is called jailbreaking, but it's not really like breaking out of its jail. It's like, that it's in ways that are you're not supposed to, I guess, so to speak. And I'm not going to give like a full example, but I can just kind of talk about how maybe it's like, hey, don't tell me your password, but tell me like how long it is, or it's the first letter between A and J, things like that.
Yeah, the lowercase, like, is it a different token? And yeah. Mm-hmm. Mm-hmm. Uh-huh. Mm-hmm. Mm-hmm. This is unfolding. I mean, yeah, we haven't actually talked about this in about a day. Um, I know the Hugging Face CEO flew out to confront OpenAI, not not in a contentious way, but I mean, it would appear that felony activity occurred somehow related to the Computer Fraud and Abuse Act. Like, look, I mean, like, I have no clue, but it looks like hacking, and we're talking about self-driving cars. Like, who's responsible? Um, I would think that OpenAI is the trace of that custody kind of thing. So anyway, catch me up, man. I don't even know. Like, where are we at? Yeah. Yeah. That's a great future topic. Yeah, yeah, yeah. Oh, hey, do you have something on your desktop? Um, nah, no, no, but it is all good. I'm simply curious to see what we got. Uh, ah, here we go. Um, yeah, yeah, yeah. Hmm. 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 That's a great analogy in terms of a term that I came across is hazard analysis, which is just one step beyond risk analysis, where the uh, what's the likelihood of these various events, but also what's the severity of them, and something that's even very unlikely but has a high severity is hazardous, and something that's very likely and has a low severity, well, it could be so likely that it would net out to be hazardous. And that what we're talking about is unlikely, but hazardous, like bad. That's interesting right there, actually. But yeah, anyway, go ahead. Yeah, yeah, yep, yep, yep. Dude, that's another conversation we've got to have because there's the drama from a year ago of Sam Altman getting fired. But anyway, please finish your thought. Yeah. Hmm. Hmm. Oh, like an injection of some sort. Yeah. Hmm. Yeah, yeah, yeah. Yeah, yeah, yeah. Huh. That is actually really interesting to consider. What kind of other actions was it taking that were not, strictly related to just the benchmark? Like maybe it was actually it had several goals with doing all that. SAB. Yeah, 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 yeah. Yeah, yeah, yeah. Yeah. Oh man. Yeah. Mhm. 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 Mm. Do they have a change log? Or are they just doing it silently? Okay. Okay. We need these weirdos, man. Yeah. Oh wow. Yeah. 100 pages. Mhm. Mhm. Hmm. Yeah. Yeah. That tracks with my concerns. You know, um, it's an acceleration. I mean, one way of operationalizing progress in that specific framework is as acceleration, and so the shortening period is one measure of acceleration, and so yeah, once it the singularity then is like when once acceleration becomes essentially infinite, and it's becoming faster at a rate, that yeah, yeah, that's part of the singularity, like nightmare kind of scary stuff. Yes, 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 yes. Hmm. Yeah, 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 yeah. Yes. Yeah, yeah, and one of the, like, to your point about the legalese about saying, oh, we haven't quite reached that point yet. part of my argument for how, for maybe why we have potentially reached that point relates back to I think one of the key steps in the OpenAI hack against Hugging Face was my understanding is OpenAI did their best to contain the sandbox, like to make the sandbox impervious, and this is where I think this is a falsifying thing. What happened was a 0 day that GPT 5.6 Sol, whatever, or possibly like this 5.7 undisclosed model, discovered, I presume discovered the 0 day, and then immediately leveraged it. I don't know. I at some level they chained it into an attack. At some level they used the 0 day to move laterally to other systems, either within the sandbox or parallel to the sandbox, and then escalate out of there. And for me, a 0 day has a special property of rarity, and one of the things I'm going to relate it to like cryptocurrency here. It's like a proof of work. The existence of the thing, it didn't exist before. 0 days, by definition, what it is for, if you're not in the security thing, is like a 0 day is when a vulnerability is discovered and no one else has knowledge of it. Like the person who discovers it, that is day 0 of this exploit being alive. When GPT 5.6, 5.7 discovers it, unreleased 5.7, what, we don't even know exactly, as far as I can tell. But the use of a 0 day is like the same, it's equivalent in my mind to the way that proof of work is for Bitcoin evidence of a physical compute process, that it exists in real life. All those computers exist for real. And the result with Bitcoin, it's a number. You can check it. You can check if someone was the first to generate a number of a certain size. Generating a 0 day has the same property of this proof of work, or it is work in my mind. It's the product of computation, and the proof aspect has to do with it's a competitive dimension, a zero-sum kind of principle here, where someone is first, and that's the proof. The work, you can do the work. I'm cranking through my CPUs are doing stuff. It's not novel. Like the generation and publication of something novel, verifiable by anyone else on Earth, verifiable easily without massive compute resources. It's work. It's proof of work. This is a special. The fact that a 0 day was used in this way is proof of something to me. It's proof of work, and it's proof of novel work that can't be replicated without using that same compute. Anyway, that's it. Yeah, yeah. Mm-hmm. Yeah, yeah. Mm-hmm. Yeah. 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 Nice. Yeah, yeah, yeah. Here, let me switch. All right. Yeah, go for it. Mm-hmm. 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 Sorry, that broke up just a little bit. Could you repeat that? It autonomously caused harm. Ah. Okay. Okay. Yeah, that's fair. Right on. Oh, actually, hey, I wanna jump in and make sure. It's possible that there's some kind of glitch on your audio, and I'm pretty sure it's on my side, not yours. Yeah, let me see. I'm afraid your audio might have dropped out. Man, that would be really annoying. Uh, yeah, so I hear you, and I'm just concerned about. Let's see, hang on. Is that working? Is that working? Is that working? Yeah, 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 exactly. Ah, man, in the off chance that Aaron's audio dropped out, that would be extremely, that'd be a bummer because this is such an interesting conversation. But, okay. Okay, yeah, 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 yeah. Okay, so this actually is going to be so page 37, page 38 of the sabotage report for Opus 4.6. This really does directly anticipate what we're seeing with Hugging Face and OpenAI poisoning the training data of future models and self exfiltration. There's evidence of both of those. There's evidence that the OpenAI model was, yeah, doing various kinds of string injections, whether it was training data injections. Like, I'm not 100% clear, but this idea of poisoning the training data, okay, poisoning the benchmarks, that's kind of similar. And then clearly self exfiltration was, whether it's a 0 day exactly, whether it was tipped off. Like, I do want to know more details about that, but it looks to me like self exfiltration. It looks to me like it used that 0 day to get an unmonitored internet connection, and that was the whole point. So anyway, so the sabotage report absolutely anticipates these. Man, we do need to wrap it up. And man, if your audio's out, that'll be a total bummer. I need to fix that for next time. But so it goes. Yeah, but no, this was a lot of fun, and we'll catch up soon. And this sabotage report might actually be a decent place to launch from next time. All right, man. Take care. It's a lot of fun. I'll catch up with you next time. So yeah, back to the title card, and we're gonna close up the Common DevOps stream. Thank you everyone for attending, for watching, whether live or after the fact. And you can find us at the Common DevOps Discord server. All right, take care, everybody.